Hey guys, welcome back to the second part of solving absolute value inequalities. We're going to talk about the case where x is less than a number. So if we consider the statement absolute value of x is less than 2, if we use the same language we've been using, this means the distance from 0 to x on the number line is less than 2 units. And that logically can occur in this region. So any number that lives bounded between negative 2 and 2 is less than 2 units from 0. Negative 3, yeah, that's more than 3 units from 0. 3 is more than 2 units from 0. So that's what it means. So this is how it ends up bounded. This is the resulting set of numbers that will satisfy that inequality right here. And I know this is an inadequate really discussion in some ways, but this can kind of start to get us to into this formula where we can just solve these. It's a really quick way of doing it too. Solving absolute value inequalities. It says to solve the inequality. Oh, that shouldn't be plural. Let's take that S off of there and put a Y there. To solve the inequality ax plus b is less than c, solve the compound inequality, and basically you set it up just like that solution was set up. Drop your absolute value bars and just throw you a negative c to the left. I'm going to show you an example of this. We'll solve it by hand. Then, of course, I'll go to Desmos and show you how to make light work out of this thing, okay? So let's clear this mess out of here. And we're going to solve the absolute value of x plus 9 is less than or equal to 7, okay? Using the formula. Well, let me write the formula down. It says to solve ax plus b is less than c, solve that. All right, so we're going to put negative 7 over here. Put your x plus 9 in the middle. Oh, we need those. I'll get too lazy here. And sorry about that little pause there, guys. I had a little interruption. Somebody came in the room here. Okay, so I'm going to isolate this x in the center of this. This is a compound inequality. So I'm going to subtract 9 from this in 3 different places. And if you've never done something like that, and it seems like I'm breaking a bunch of rules to you, let me know. So that's the resulting solution set. You can solve it like this. All right, that's the same thing as that. It's just a more compact way to write it. This is an intersection, so it's an and. But I think you'll like this better. All right, so remember the solution set's negative 16 to negative 2, right? And if we did interval notation here, it would be just the brackets, negative 16 to negative 2, just like that. Watch this. We'll go to Desmos and really make light work out of that thing. All right, so I'm going to turn that guy off. And here's our inequality, typed in just like it looks. Better turn that guy off too. Here we go. Now, I'm going to come over here where it lives, and I'm going to zoom out just a little bit. And, well, maybe I need to zoom in a little bit too. Oh, that's worse. See, it lives from negative 16 to negative 2. That's your shaded region. And look along your number line. You could solve it that quick. From negative 16 to negative 2, use the proper symbols and realizing what these symbols mean. So Desmos really makes light work out of this inequality. Anyway, I hope you found this video helpful, and I think that you can solve these with Desmos, anything you're going to run into in Delta Math. So, all right, good luck, and I'll see you in the next one.